Hello, ladies and gentlemen. Okay, so in this video, we are going to be going over the sine rule in trigonometry. So the sine rule is a way of us using our trig ratios on non-right angled triangles. So the sine rule is a concept introduced in Leaving Cert. You have to cover it in both ordinary and higher level, but in higher level, you could be asked to prove this. So it's very important that you learn the proof alongside this as well. So what is the sine rule? I'm so glad you asked. So the sine rule simply states that the ratio, or if when I divide one side by the sine of the opposite angle to it, it's the same for every side angle. So A divided by sine A, so a sine of angle A is the same as B divided by the sine of angle B, which is the same as side C divided by the sine of angle C. So it's the same for every single triangle. So when do we use the sine rule? So we use the sine rule so when we have two angles in one side, opposite one of the angles, so the side is opposite one of the angles, or when we have two sides and one angle, right? And the angle is opposite to the one of the sides that we're given. So let's have a look at this question here. So we're asked to find what x is here. So I have one side and I have my two angles, and one of these angles is opposite the side given, so I am able to use my sine rule. So I know for a fact, ladies and gentlemen, use my sine rule above here, right? 12 divided by sine A is going to be equal to x divided by sine 50. So sine A, oopsies, I should say sine 30, right? Because it's opposite to 12. So 12 divided by sine 30 is equal to x divided by sine 50. So 12 divided by sine 30, if you put that in your calculator, make sure your calculator is in degree mode, I am going to get 24. So 24 is equal to x over sine 50. I want to get x on its own, so I'll multiply both sides by sine 50. So I have 24 times sine 50 is equal to x. X is going to be equal to, put this in your calculator, 24 sine 50. I'm going to get 18.385, and it says round to two decimal places, so it's going to be 18.39, and I don't have any units, so x is equal to 18.39, close the bracket, and highlight. There you go, that's my answer there. So that is a very simple application of the sine rule, so that's showing us how we can use the sine rule to find a missing side. Here, we are asked to find a missing angle. So to find a missing angle, let's see what I have. Well, I have two sides, ding, and I have an angle, ding, and the angle is given is opposite to one of the sides, bada boom, bada bing. So I can use my sine rule again. So I know for a fact 10 divided by sine 30 is going to be equal to 15 divided by sine A. So I need to find what this angle A is. So, fun little fact, if I have two fractions equal to each other, their reciprocals are going to be equal to each other. So 10 over sine 30, right, equals 15 over sine A. Well, that's the same as sine 30 divided by 10 is equal to sine A divided by 15. It's just going to make it easier for us now to calculate what sine A is. But if you can't remember this, we can just use basic algebra here. So I'll multiply both sides by sine A. So I'll have 10 divided by sine 30 is going to be 20 anyway. So I have sine A multiplied by 20 is going to be equal to, well, sine A divided by sine A is going to be 15. Then divide both sides by 20. So sine A is equal to 15 over 20. A is going to be equal to, so remember we have to use our inverses, so sine inverse 15 over 20. Angle A is going to be equal to 15 over 20. 48.59 degrees, right? And the same goes for over here as well. So I have Sine 30 divided by 10 is equal to sine A over 15. So I use my reciprocal property there. So on the left-hand side, I am going to have something. Don't know what it is yet. Let me put it in my calculator. Bada boom, bada bing. 1 over 20 is equal to sine A over 15. Multiply both sides by 15. So I'm going to get the 15 over 20 is equal to sine A. So, and then, of course, A is going to be equal to the 48.59. So that's two ways of doing it there. So you can do the long algebra way here on the left, or if you just remember your reciprocal property, I can just flip the two fractions upside down and let them equal to each other. So there are just some not practical, what's the word for it? Well, that's just practicing the sine rule, but the sine rule can come up into some actual real world applications now. So here are questions that you could be asked on your leaving cert. So ABC is a triangle and D is on the line BC. This is loading now. So let's have a look here. Bing, 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 bing. There we go. So ABC is a triangle and D is on the line BC. If the length of BD is equal to 4 centimeters and the length of AC is equal to 6 centimeters and the measure of angle ACD is equal to 65 and the angle DAC is equal to 70, find the length DC. So to the nearest centimeter. So DC. So I have a big triangle here. I see I can make it up into two triangles. So I'm going to make it into two triangles here. So if I look at this purple triangle I have here, well, what do I have? Well, I have a side and I have two angles. But remember, one of my angles has to be opposite the side, right? One of my angles has to be opposite the side that we have. And I don't have that angle because I need it because that corresponds with the 6. But I do know every angle in a triangle adds up to 180. So 180 is going to be equal to 70 plus whatever this angle is. I'm just going to call this angle theta. Plus 65. And then I know that that angle is going to be equal to 45 degrees. Okay, now I can use my sine rule, right? So looking here, I can see, well, I have 6 divided by sine 45 should be equal to x divided by sine 70 because I'm looking for DC. So I'm looking for length DC. I just labeled it x. And I have the angle opposite it, gorge, and I have my side 6 here, and I have the angle opposite. So sine over 6 over sine 45 is equal to x over sine 70. Well, I want to get x on its own, so it's being divided by sine 70. So I multiply both sides by sine 70. So sine 70 multiplied by 6 over sine 45 is equal to x. So sine 70 times 6 over sine 45. I'm going to get here, x is equal to, it says to the nearest centimeter, so I have 7.97. Well, to the nearest centimeter, it's 8 centimeters. So the length DC is equal to 8 centimeters. Gorge. And that's 45. Okay, so part 2 is asking us to find the area of triangle ABC correct to the nearest centimeter squared. So triangle ABC, so that is the big triangle here. So if you recall from the area of a triangle from my previous video there, so it's a half AB sine C. So I just need two sides of my triangle and the angle to trapped between them. Well, I have one side of my triangle. It's going to be 6. I'm going to label that A. Do I have another side? I do. I have my bottom here. So I have B to C here. Because if B to D is 4 and D to C is 8, that means this whole side is equal to 12. So I have that side now, I'm going to label that B, and I have the angle 65 that traps between them. So the area is going to be equal to a half times 6 times 12 sine 65, which is going to be area is equal to 32.63 centimeters squared. And it says round to the nearest, so it's going to be 33 centimeters squared. So the area is going to be 33 centimeters squared of the big triangle ABC. So another question you could be asked is like here. So the diagram shows two parallel banks of a river. The angle from 2 points O and S on one bank to a tree on the opposite bank are 38 and 47 as shown. Find correct to the nearest meter the distance from O to the tree and the width W of the river. So I first need to find this length. Right, so it's asked me to find distance from O to the tree, and then it's asked me to find the width of the river. So, what do I have here? Well, if I look at my big triangle here, if I look at the big picture, so I need two sides. I need a side and two angles. So I have one side 50, but I don't. And I have two angles, but one of these angles isn't opposite my 50, so that's a problem. But I know what this angle is going to be here because all angles in a triangle add up to 180. So I'm going to have 180 minus 38 minus 47. So this is going to be 95 degrees. So this angle here is going to be 95 degrees. And now I can use my sine rule to find the length here. So I know for a fact that 50 divided by sine 95 is going to be equal to x divided by sine 47. So multiply both sides by sine 47 so I can get x on its own. So sine 47 times 50 over sine 95 is equal to x. Put this in your calculator, sine 47 times 50 over sine 95. And that's going to be equal to x is equal to 36.7 meters, but it says to round, so it'll be 37 meters. So the length from O to the tree is going to be 37. Now, part 2 is asking us find the width of the river, find W. Well, I'm not using my sine rule this time. I'm actually going back now to my normal trig ratios, because if I isolate this triangle here, I have a right angle triangle now. I have the angle here. I have a side, and I'm looking for this one. So this is going to be my opposite. This is going to be my hypotenuse, and I have an angle. So we're going to be using my sine ratio here. So sine of 38 is going to be W over 37. Multiply both sides by 37. So I'm going to get 37 sine 38 is equal to W, the width of the river. Put that in my calculator. I'm going to get the width of the river is going to be equal to 22.779, which is going to round to 23 meters. So the width of the river is 23 meters. Right? Gorge. So, last problem to have here. So a farmer is making a triangular pen bounded by a fence 59 meters long, a hedge 68 meters long, and a wall. The angle between the wall and the hedge is 49 degrees. Draw a rough sketch of this angle. Woo-wee. Okay, so we have to be a bit artistic now, ladies and gentlemen. So I'm going to draw a triangle here. No, I'm not. That's a lie. I'm going to use this. Will I use that? Nah, actually, I won't use that. So I'm actually going to draw a triangle here. Bing, bong, bing. Right? So He has a triangular pen, okay, surrounded by a fence, a hedge, and a wall. So a fence, 59 meters long, a hedge, 68 meters long, and a wall. So it doesn't tell us the length of the wall. So you can label whatever size you want. So I'm going to label this as my wall. I'm going to label this as my fence, which is 59 meters long. And I'm going to label this my hedge at 68 meters long. So I have a triangle here, and it says the angle between the wall and the hedge is 49 degrees. So from here to here is 49 degrees. So find the measure of the angle between the fence and the wall, correct to the nearest degree. So the fence and the wall. So we're asked to find the measure of this angle here. The measure of that angle. So let's have a look, right? I have two sides, 59, 68, and I have an angle, which is opposite to one of the sides, 49. So I can use my sine rule. So I know for a fact 59 sine 49 is going to be equal to 68 divided by sine theta. So again, I have two fractions equal to each other. So I can just let their inverses equal to each other. So I know sine 49 divided by 59 is going to be equal to sine theta all over 68. Now I want sine theta on its own, so I'm going to multiply both sides by 68. So the 68 will cancel here. So I'm going to have 68 times sine 49 all over 59 is equal to sine theta. So 68 times sine 49 divided by 59. That's going to be equal to 0.86983 is equal to sine theta. So find the inverse of that. 0.86983. So theta is going to be equal to sine inverse 0.86983. Theta is going to be equal to 60.44 degrees. And it says correct to the nearest degree. So it's going to be 60 degrees. So the angle in between the wall, or the fence and the wall, I should say, is going to be 60 degrees. And then, since I know that, I can calculate the angle between the fence and the hedge. Right? And the fence and the hedge, that angle is going to be 71. So, I got loads of information now from that part here. So, let's look at the second part. Find the length of the wall correct to the nearest meter. Well, again, now I have all my angles on my triangle. Now I'm just looking for the wall. So using my sine rule, I know my wall W divided by sine 71 should be equal to 59 divided by sine 49. Now you could use 68 divided by sine 60. For me, in the exam, I would just always use the bits you're given first, because you know, if you got part 1 wrong and you use that in part 2, you might lose some marks. So just, if you can, use the bits you're given anyway, just be safe. So I have the length of the wall divided by sine 71 is equal to 59 divided by sine 49. So I'm going to multiply both sides by sine 71. So I'm going to get W on its own now. So W is going to be equal to sine 71 multiplied by 59 divided by sine 49. Put that in your calculator. You're going to get sine 71 times 59 divided by sine 49. The wall is going to be equal to 73.9166, which I'm able to round now to 74 meters. So the wall is equal to 74 meters in length. And then finally, part 3, find the area of the pen correct to the nearest meter? Well, again, so recall, a half AB sine C is my area formula. So I just need two sides and then an angle trapped between them. So I don't know, right? Fence 59, hedge 68, and I have the angle 71 trapped between them. Gorge, right? So I'm gonna label that A, B, C. So I'm area is equal to a half times 59 times 68 sine 71. So 0.5 times 59 times 68 times sine 71. The area is going to be equal to... Oh golly, that's very big, very big. 1896.71 meters squared. It says correct to the nearest one. So it's going to be 1897 meters squared. That is how big the area of our triangular pen is going to be. Right? And that's it from me, ladies and gentlemen. I have nothing else to add really. So in the next video, we are now going to be doing the cosine rule, and that will kind of complete that area of trigonometry anyway. So yeah, so I'll catch you on the flip side. Peace.